Lesson 8.2, multiplying a polynomial by a monomial. Our objective is to multiply a polynomial by a monomial and to also solve equations involving products of polynomials. The algebra standard is Algebra 1 6.4. Basically, multiplying a polynomial by a monomial is otherwise known as distributive property. So we have already done this. We've done it early on in pre-algebra. We did it at the end of the year to prepare for Algebra 1. We did it at the beginning of this year. So you should be pretty well set to do this lesson without too much extra instruction. So the first example, 4 times the quantity x plus 2. If I distribute that 4 through there, somebody tell me what that would be. Avery. 4x plus 8, because you take 4 times x and then 4 times 2. Okay, so we're just going to build these up a little bit. Now I've got 6y times the quantity 4y squared minus 9y minus 7. And as I distribute that through there, what would we do? What would it be? Anybody want to try? All right, Ben. First, 6y times 4y squared, what would it be?
24y squared?
No.
24y cubed?
Yes. 4y, or 24y cubed, because as I'm multiplying y times y squared, that has the same base. So I have to add those exponents. So definitely 24y cubed. Okay, now 6y times negative 9y, Ben, what would it be?
Minus 54y squared.
Okay, minus 54y squared. And then 6y times negative 7, what would that be?
42y.
All right, what sign?
Oh, negative 42.
Minus 42y. Positive 6y times negative 7 is minus 42y. And that is it. None of those are like terms. Your answer is simplified. You're done. Questions there? All right. Let's check out the next example. This one has a couple of distributives, so you got to be careful with it. You got to do both of them and then go back and check and see if you have any like terms that you could combine. So 3 times the quantity 2t squared minus 4t minus 15, and then we're going to add to it 6t times the quantity 5t plus 2. Anybody want to try this one? Okay, Octavia, let's take 3 and distribute it through there first.
6t squared.
6t squared, okay.
Minus 12t.
Minus 12t, and then
Minus 45.
minus 45. All right, so that's the first one. Now, we're going to add to it, we've got 6t times 5t.
30t squared.
30t squared. Okay, and 6t times 2.
12t.
12t. So, what you've got to do now is combine like terms while also putting it in standard form. So, what's the highest exponent on t? Squared. So I've got 6 of them here and 30 of them here. Together, when I combine them, what would it be?
36t squared.
36t squared. Okay, so then you take your exponent on t down 1, so we're talking regular t. I've got negative 12t here and positive 12t here. What's going to happen with that?
It cancels out.
Cancels out. We're not going to have a t term at all. And then the constant term, there's only 1. So what would I do, Octavia?
Bring it down.
Bring it down, minus 45, and I would be done with that. 36t squared minus 45. All right, so make sure you distribute through, combine any like terms as necessary, put it in standard form, you'd be done. All right, now we're going to solve some equations. This is definitely multi-step equations at its finest. You follow the 4 steps, you distribute, combine like terms on the left, combine like terms on the right, bring your variables together, and solve and get that variable by itself. Jared.
First, you would distribute the
Okay, so we're going to take b times 12. What? Okay, so b times 12 is going to be, I couldn't hear what you said. 12b, and then b times b is b squared. And then bring down minus 7. Definitely bring down your equal sign, don't forget that. Bring down 2b. Now, b times negative 4, negative 4b, and b times b, b squared. Okay. Now, here's the thing. You look for like terms on the left. Do I have any like terms on the left? No. Do I have any like terms on the right? Yes. So what are they? 2b and negative 4b. So let's combine those. What would that be? Negative 2b. And I still have a b squared here. Over here, 12b plus b squared minus 7. Now, Jared, we've never really dealt with equations that had b squared in them, but I'm going to tell you, you have to deal with that first. How would you get those to go away or go to the opposite side? Yeah, so subtract b squared, and the thing is, you got to do it on both sides. So thankfully, those will fall out because we haven't solved any of those just yet, but it's coming very soon. Okay, below that line, Jared, what do I have left? 12b minus 7 equals. Okay, generally at this point, we try to find the lower exponent on my variables and move that over. So we can do that, or we can bring the variable to one side. So it's really a toss-up where we go from here. But you've got to deal with the b's. What do you want to do?
Add 7
Nope, we got to deal with the b's.
Add 2 b's.
All right, let's add 2b to each side. Let's do that. And when I do that, on the left, I have what? 14b, and then minus 7. What's the right going to equal? 0. Okay, I'm going to bring this back up here because I'm running out of space. 14b minus 7 equals 0. Okay, so my variables on the left, I got to take that 7 over to the right. What would it be? Add 7. So 14b equals 7. Now what, Jared? Divide both sides by 14. So what's my final answer, Jared? 1/2. Okay, do not divide that out and get a decimal. Just leave it 1/2 and you're done. Okay, 1/2. So if you end up with any terms that have exponents other than 1, they're going to end up falling out. I promise you, because we don't know what to do with those just yet. All right, questions about that problem? Lots of steps involved in there. Okay, but I think you're up for it. Let's see if we've got another example. Oh, we do. There's an E. Okay, awesome. Who wants to do this one? My tree? Let's do some distributive. There's lots of it here to do. X squared plus 2x plus 2x squared minus 6x plus 7. Okay, and then on the right, 3x squared minus 15x minus 12. Oh my goodness, we've got all kinds of like terms, don't we? On the left, what are some like terms, my tree? X squared and 2x squared. When I put together, what would it be? 3x squared. Anything else? 2x and negative 6x. So what would that be? Negative 4x. And then anything else? Nope. So plus 7 just comes along. On the right, do I have any like terms? Nope. So they just come along. 3x squared. Oops, not cubed. That'd be a whole different problem. 3x squared minus 15x minus 12. Okay, what do you think I got to deal with first here? The x squares. What am I going to do with that? Okay, so subtract 3x squared from each side. And thankfully, like I said, That's going to make them both go away. We can't deal with that yet, but it is coming soon. So below that line, what do I have, my tree?
Negative 5 plus 7 or negative 15 minus 4.
Right. Okay, now, get variable on one side. Which one am I going to move? Okay, negative 15x, and I'm going to move it by doing what? Adding 15x. Okay, and when I do that, what's going to happen? 11x plus 7 equals negative 12. And now what? Subtract 7. So 11x equals negative 19. Oh my, where am I going to go from here? Divide by 11 on both sides. And what do you think our answer is going to be? Yep, x equals negative 19 over 11, and don't change a thing. There it is. So obviously, they're going to be multi-step equations that you can work with. It's just the answers are going to look very strange. Okay, question.
Would it be negative 19 elevenths instead of negative 19 over 11?
I get exactly what he's saying. He's saying that I should just put this right out here in front, right?
Yeah.
Is that what you're getting at?
Yeah.
Very good. Yeah, yes, you can do negative out in front, and it is 19 elevenths. Good job. Any other questions?